Good evening. Welcome to our TI Technology webinar hosted by Texas Instruments. This session is For the Love of Data Collection. I am Ruth Casey and I'll be the host for the event. We have quite a few people signed up to join us for the live event, so you may have noticed as you connected, you were automatically muted. That will be the case throughout, but the chat panel is available to us. So make your way to the chat panel if you wish to share comments, ask questions, and read what other attendees are sharing. We do ask that you find a selection that's usually called Everyone from the drop-down menu so that you can share comments with everyone and we can see them. If you want to give it a try now, go ahead and shout your name and location. Or if your WebEx name is the one you're using, that's great. Just share out a location. While you're doing that, adjust the layout to be just the way you want it to be. Personalize it for you. Okay, as you're looking at the chat panel, seeing who's joining us and what they're sharing, just want to remind you the session is being recorded and it will be available for viewing or reviewing later. If you experience any audio or video issues that can't be resolved during the live session, please feel free to watch the recording later. Also, options for sharing via social media, sharing what you're learning during this exciting event about data collection. I'm so pleased to have an outstanding educator with us as the presenter. Jeff Lukens, thank you so much. Please say hi and tell us a little bit about yourself.
Well, hello, Ruth, and hello to the growing number of people who are joining us tonight. I am a retired science teacher. I live, as you can see on this slide, I live in Sioux Falls, South Dakota, which is, if you like directional stuff, that's in the bottom right-hand corner of South Dakota, actually, the southeast corner. And I had a 35-year teaching career, and after I retired, now I spend time with teachers in their classrooms and in PD, helping them learn how to use Texas Instruments technology. And I got to give a shout out to your host tonight. I have the opportunity often to work with Ruth Casey, and just tickled that she's here with us tonight. So thanks, Ruth.
Thanks, Jeff. We have a slide there about what's going to be happening during our next 57 minutes together. If Jeff wants to share any more about it, he can add to that now or certainly as he goes along through the presentation.
Yeah, we'll be doing, as the title of the session implies, we don't want to do any false advertising here. So we will be doing data collection, and I'll reference some different forms of data collection that you can use. Some use technology, some do not. We'll be using a couple of sensors for sure, and my gut tells me that we probably will only get to those two, and the one is the EasyTemp sensor, which we will use first, and then we'll move to what's called the gas pressure sensor. The CBR2, which is a motion detector, our chances are we may not get to that, but I will reference it and let you know what that's all about. And then Ruth can tell you about the kind of the culminating event of all these webinars is we have a drawing for what, Ruth? What can they win?
They can win a calculator. Yes.
Oh my gosh.
One person attending this live event who will have the opportunity to tell us which model they want, a TI-84 plus CE or a TI-Nspire. That'll happen towards the end.
Awesome. We always like to provide for you some outcomes that we expect to accomplish and get done by the end of our time together. And so kind of starting at the top left and working our way around clockwise, I can connect an EasyTemp sensor and collect temperature data, which we will do not together necessarily, but you will see me do that for you as a demonstration. And hopefully you'll be able determine that it's really pretty easy to do it. That's why they call it an EasyTemp sensor. And then in order to use the sensor, we use an app within the TI-Nspire software, and that app is called the Vernier Data Quest app. Many of you, if you are science teachers, especially if you teach physics, you certainly have heard of and are probably familiar with Vernier. Vernier makes the sensors that interface with the TI technology as well. One of the things that we will spend quite a bit of our time on is integrating mathematical modeling and analyzing graphs that we generate by collecting the data using these sensors. And then the bottom right hand one, I think this is in a way the most important. Everything else is sort of a mechanical outcome. This one is like a big picture outcome. I can see the value in having students collect their own data. And I will make reference to that as well, how in my experience, my own classroom, and now as I work with teachers and students in their classrooms, the level of enthusiasm and the level of buy-in and engagement and whatever other education words you want to use is way better when the students are collecting their own data. So that's what we're hoping to get accomplished this evening.
Okay, we'll keep an eye on the chat, and Jeff is going to share with us some information from his desktop. We're going to be looking at some applications that he has.
You bet. Let me go ahead and share this, and let's make sure that everyone can see this. Ruth, I'll count on you since you're the only one not muted to let me know if you're able to see what I'm seeing.
I think I see what you're seeing. If you're seeing a calculator keypad on the left and a Vernier EasyTemp probe in the center of the screen.
Beautiful. You know, I do have to make reference to Ruth, you were probably watching this and everyone else might have been watching where people were signing in from. We have a real diverse geographic area for sure, international. But Ruth, my favorite city so far, and if this is you, you may not win the calculator, but you want a shout out from me, Yazoo City, Mississippi. I have never heard of Yazoo City, Mississippi, but I will not forget that name of that city. So if that's you from Yazoo City, rah rah, there you go. Okay, so let's go ahead and get started. What I wanted to show you first, before we do any data collection at all, since I don't have my video running, because my experience has been that can be a little bit distracting for you and for me. So I wanted to show you the tools that we're going to be using tonight. The main tool, the workhorse of the entire webinar and the workhorse of the entire data collection world that I live in is called the TI-Nspire. TI-Nspire handheld graphing calculator. You can see over here, the TI-Nspire that we're using is the TI-Nspire CX. Now this is the software, the teacher edition premium software that we're using, but what you see on the calculator is exactly what I would see, what I am seeing here on this computer. Can it be, I happen to look, Steve, at your chat message. Can it be done on the 84? Yes, it can. Everything we're doing tonight can be done on the TI-84 handheld as well. And that's a great question. All right, so let's go through some of the, and Ruth, by the way, we've worked together a lot. I'm going to have to kind of count on you to monitor the chat and keep track of questions and interrupt me anytime to answer those. Steve, you just lucked out. I just happened to look over there when yours popped up. This device that you're seeing on the screen is the Vernier EasyTemp probe. As you can see, that's the first device we're going to use. Vernier makes several different types of temperature probes. And chances are that some of you have used them before, at least one. The EasyTemp is it lives up to its name. It's a plug and play device. It's got a mini USB connector right here. I think hopefully you can see me kind of circling that with the cursor. There's a mini USB. It's got about a 4-foot, little over a meter long cable. And once you plug it in, you'll see in just a moment, once you plug it in, you will see that it's very easy. It activates the app and it activates the calculator immediately. So we will be using that. The second tool is one that you do not need with the EasyTemp, but you do need it with almost every other probe that you're going to directly plug into the TI-Nspire or the 84. This is called a Vernier EasyLink. And I know this is a TI webinar, but I need to let you know where you can find this stuff. If you go on the Vernier website, it's just vernier.com. These devices are available from Vernier on that website. Vernier makes somewhere near 90 different data collection sensors. Some of them are workhorse sensors that you would use many, many times during a school year. Some of them are very, very specialized, and you may only use them once, if at all. The ones we're using tonight are multi-purpose sensors, but many of them require this adapter called an EasyLink in order to plug into the TI-Nspire. You can see here's that same mini USB that plugs into the top of an Nspire or the side of a TI-84. The other sensor we're going to use is called a Vernier gas pressure sensor. This is a really nerdy statement, but this is actually my favorite sensor of all because, a temperature probe you can use to collect temperature data. There's all kinds of stuff you can use. You can use thermometers. I mean, back when I was a student, way, way back, we used thermometers. There were no electronic or digital data collection devices available to us, at least that were not cost prohibitive. So we use thermometers. You can still do that. You can use other devices to just measure relative temperature changes. Nowadays, I like to tell teachers there's really no excuse for a teacher, especially a science teacher, and those of you who are math teachers, I'll come to you in a little bit. There's really no excuse for a science teacher not to do data collection if they have that built into their curriculum. And these devices make that process pretty easy and quick. Quick is the big deal. All right, so here's the actual sensor, the gas pressure sensor that we're going to use. The only two pieces of this kit that we're going to use tonight are the actual sensor right here and the syringe. This is a 20 cc or a 20 milliliter syringe. Okay, we'll be using that. These other devices, there's a stopper, a large stopper, a small stopper, some clamps, some tubing, and so on. But all we're going to be using is these two things. Now, if you look right here, this connector will not fit into the TI-Nspire or the 84. However, that connector will fit into the EasyLink. And so you plug in this case, the gas pressure sensor into the EasyLink, plug the USB into the TI-Nspire, and away we go. One more thing. Now, I'm collecting data tonight on a computer. That brings one more piece into the game. In order to connect to your computer, at least my computer, I need one more adapter, and it looks like this. This is called a Vernier Easy2Go, love that name, Easy2Go adapter. This is a standard USB that plugs into the computer, and this is a receptacle for that mini USB insert. Okay, so that's what we're going to be using, and right off the bat, I'm going to be using that connected to an EasyTemp sensor. So Ruth, I haven't been on. If there's a question that somebody came up with as far as structurally what we're doing tonight and how you get these things connected, interrupt, chime in. But if not, I'm going to go ahead and proceed, and we're going to do some data collection. Before we do that, before we collect data, I just want to tell you that to do data collection, you don't need fancy equipment. If you have this type of equipment, great. It, I think, raises the interest level of the students. It raises the accuracy of their data collection and so on. But there's lots and lots of ways to collect data that don't involve electronics. I mean, you can use yardsticks, meter sticks, rulers, string. There's all kinds. You just use your imagination. I mean, back before we had these kind of things, we would do things like measure your height, put kids up against a wall, measure how tall they are in centimeters or whatever, and then measure the length of their hand span, and then put those two things into a data table and compare them and see if there's a trend. That is data collection. And just because we have cool ways to collect data electronically doesn't mean you can collect data in virtually any way that you want. and it's usable, it's valid, and it integrates student involvement in your data collection plan. Okay, so here's what I'm going to do. I'm going to go into the computer software, and I'm going to open a new document. So if you're not familiar with the software, you're going to see this pop up in just a second. You can see at the bottom of the screen, I have that previous file still open. Just like in Microsoft Word, you can have multiple Word documents open at a time and so on. And this is a new document just waiting for me to tell it what to do. And I'm actually not going to click on any of these apps. What I'm going to do is I'm going to take that temperature probe and plug it in. I'm not doing anything tricky here. I'm just going to plug in the Easy2Go adapter with the temperature probe attached to it into the computer and watch what happens. Ooh, that's not what I want to have happen. Let's try that again. Okay, so if this is going to be naughty, then we're going to have to adjust. Okay, try one more time. Now, believe me, I know this is with electronics and with technology, you can always say, well, it was working before, and it actually was.
So with your TI-Nspire and with the TI-84 calculator, what we expect to happen, as you mentioned, it's a plug and play device. So when you plug it in, the app pops up on the Nspire. It's this app that we're seeing now on Jeff's, and on the 84, it's the Easy Data app.
Okay, so you know what I'm going to do, you guys? Ruth, you want to keep talking for a minute? Because what I'm going to do is shut down this, not only this file, but I might restart my software.
Okay.
You
Um,
good?
I want to remind people about the chat window that we have. So while Jeff was talking, he mentioned the data collection products um, from education.ti.com. He mentioned that there were several data collection things. I'm going to share my screen so that we can see some of the things that he was talking about. So there, I went to the main education.ti.com site. Okay, we're educators, so education comes first, education.ti.com. And there's what the home screen looked like. Let me, a little bit of lag here. So there's the home screen. I went into products, the drop down, move over to data collection, and it gives me a lot of possibilities there. I put links in the chat for this page. On this page, we see featured the CBR2 motion detector and the temperature probe that Jeff is, in a few minutes, going to plug into the computer that he's using. All right. So there's even more. You can click on that and get even more opportunities for data collection. I did share also some links about let me see. Here we have, it's called Easy Data. It's the app that is on a TI-84. There we have an 84 Plus Silver Edition. It always also comes on the 84 CE, the latest model, and the 84 CE Python, the latest models of that. So from education.ti.com, click on products, move over to data collection, and you'll find options for some of the things Jeff is going to show us tonight. Also, in the chat, I put the link for, I lost my chat window, sorry. I put the link for the interface that Jeff shared with us. Okay, so
Okay,
look,
Ruth.
scroll up and down your chat and copy some of those links if you'd like to, but they're really easy to find. Oh, in the chat, somebody said, is it already built in or does it have to be loaded? The app comes on the device. On the TI-Nspire, Your data collection app is there, and on the TI-84, the app comes on a new handheld as well. Is it your turn, Jeff?
It is, but the old saying is I'm going to change horses in the middle of the stream. We are going to do a data entry and we're going to analyze. It's one that I think you guys will like. And this USB device is being naughty. And so we're going to make lemonade out of the lemons that we've been given. So you know what, Ruth? I'm going to go ahead and we're going to do something. Okay.
Okay, so go ahead and
Check it.
share
And
your
this might actually,
application.
yep, I'll go ahead and share it. And this
Perfect.
actually, for some of you, if you don't have this equipment, this is one of those activities that you could do tomorrow. If you have school tomorrow, you could do this activity with your students tomorrow. If you have a graphing calculator, whether you have a graphing calculator or not, I mean, it's cooler on a graphing calculator like this. But what we're going to do is manually activate one of these apps. And if you have any experience with TI-Nspire, you know, these are called apps. Then down here at the bottom, there's two coding apps, and the newest one is coding with Python. The original TI-Nspire had, I believe, 7 of these, and we're going to make use of 2. We're going to go ahead and open up a list and spreadsheets. Now, if you have a TI-Nspire with you right now, and you want to play along, I would say do it. I mean, this is going to be, or you have TI-84, rather than lists and spreadsheets, you're going to have the list menu, but we're still going to be able to generate a graph from that. So we're going to go to a lists and spreadsheets app. If you're new to TI-Nspire, this app is very, very similar to Excel. I mean, it's not as powerful necessarily as Excel, but the commands are similar and the process of entering data is also pretty much the same. So what I'm going to do is move up to the top of column A, so the column heading. And this is where we are going to name this list of data, okay? So what I'm going to call it, and if you don't mind, I'm going to use my computer keyboard rather than using the calculator keyboard over here because it's way quicker. So we're going to call this first set of data, or this first column of data, weight. Okay? W-E-I-G-H-T. Now notice if you have not used Nspire before, we have an italicized font. And when I press the down arrow over here on the calculator, or if I press enter, watch what happens to the font. It is non-italicized now. And right now, what we have just created is a variable called weight. So the calculator slash computer is going to associate everything in that column with the variable weight. Okay, so let's go over to, before we put any numbers in there, let's just go over here to column B. This activity, before I put in what we're going to be entering in column B, this activity has a high level of interest for every student I ever worked with. And I'll tell you what the end game is here. The end game is for them to predict something about themselves based on a data set. So this one I'll actually show you that I can kind of use the little keys over here on the keypad. We're going to call this one PINTS. So we're going to call that pints. Now, with my sincere apologies to our friends who don't use the American system of units, we could easily make this liters. We could easily make column A mass, okay, if we chose to, but I'm just going to leave it as pints. Okay, so again, we created a variable. So now in the column that says weight, this is going to be body weight. We're going to build a baseline based on some standard body weights. Okay, so here's what we're going to start with. We're going to start with 60 pounds. So this is going to be weight in pounds, and there's ways to put that pounds thing up there in the variable name. But we're just going to go weight 60. And now one of the most important things we can do as educators who say that we believe in STEM STEM. And I know some of you have in your state or your district, you might call it STEAM. There's all kinds of different ways to represent it. But one of the things that I tell science teachers who are very hesitant to use math because they're either not comfortable or they say, this isn't a math class, this is a science class. That one causes me to grind my teeth a little bit. But as a science teacher, and I was a biology teacher, and sometimes it seems like math isn't quite as much of a deal in biology as it is in chemistry or physics. But here's a comment I always make to young teachers, especially if there's math staring you in the face, don't ignore it. Or if there's an opportunity, excuse me, if there's an opportunity to do some math, take it. Because that to me is what true STEM is. In your science class, not ignoring mathematics if it's there. I'm not saying you have to do calculus in your freshman science class. That's not it at all. But if there's numbers, if there's some arithmetic, if there's some mental math to be done, I would encourage you to take advantage of that opportunity. Okay, now well, here's what we're going to do. We're going to increase the previous weight by 24 pounds each time. So 60, the next one we typed in there, I typed in there was 84. We're going to go to 108. 24, we add 24 to that. I think we got 132. And we're going to keep doing this until we get to 300. So 156, I think next is 180. And this seems like a beatdown to kids because, you know, they'll say, this, well, I thought this was a science class. This isn't a math class. Well, if you're a math teacher, this is a really, really good one to use in your algebra class or your pre-algebra class. There's some really cool stuff that's going to come out of this. 232, 250. I don't have a sheet in front of me because since the computer and the USB thing kind of went funky on me. Am I doing this? 24. So you know, it really doesn't. What did I miss here? Let me just go to 300. We'll be okay. I must have goofed up one along the way. So we're up to 300 pounds. Now what I want to do is go over to column B. Now when I say pints, some of you are already predicting what this is going to be. And this calculation or this subsequent cells, this is way easier mathematically. Pints here is pints of blood. The amount of blood that you have in your body or that a human being has in their body. We're going to start here with 5 and go up by 2s until we reach the 300. And if somebody can catch the mistake, I must have made a mistake on the previous column. I can go back and check it, but we'll just keep going. So 15. Now some pints are fun to use because most people, doesn't matter if they're kids or adults, sometimes they're like, I really don't know how much a pint is. A pint is a standard water bottle. That's about a pint, maybe it's a half a liter, but it's still pretty close to a pint. A liter is about equal to a quart. So the transfer is pretty doable. I think my goof up might have been right here. That should be 228. Now this, I could say I did that on purpose because this shows you how easy it is to correct an error. This would be 252. 276. There we go. All right, so now we're good. So now the idea here is to build a graph from which we can make predictions. The prediction is going to be, and again, with students, I wouldn't tell them this right off the bat. I'll tell you guys. The prediction is going to be how much blood, this is from the kid's standpoint, how much blood do I have in my body? The students really don't care how much blood I have in mine or how much the person sitting next to them has, but they do have an interest in their own. I saw a question pop up, can you put in a formula and have it fill a column? Yes, you can. Here's a formula line right here, and we can actually put in a formula to populate with including the interval, including the step to populate that column. All right, so now we get the data in there. What we want to do now is take a look at a graph of these data. Most students I've worked with prefer and glean more from a picture/graph than they do from simply looking at a data set. However, I would spend some time on the data set and saying, what's the relationship between these two variables? What's happening with the weight? In fact, I always said to my students, I'll give you a hint. I'll start the answer for you as, and that's all I give them. They got frustrated with that. But as what increased, the other one increased. So that kind of brings to mind and brings to the forefront which of these two variables is dependent on the other. Okay, so be thinking about that. Is the amount of blood you have dependent on your weight, or is the amount of the number of pounds you weigh depending on your blood, dependent on your blood volume? Okay, so let me show you how we can get a graph. If right up here at the top, there's a command called insert. However, let's pretend you don't have the software. Let's pretend you have the calculator, and we're going to insert a page. If you look at this button right here that says DOC on it, right above it in blue, it says plus page. So I'm going to press the blue button. If you're an 84 user, this would have been like the second button when you do second something on the calculator. Control dock, and we see the same menu that we saw when we first opened up a new document. Now you might think we're going to go here, and that would be fine. We could go there, but let me just assure you where we want to get and the goal we want to accomplish is much more difficult to accomplish using the graph, in my opinion, using the Graphs app than it is using this one. Number 5, data and statistics is a little bit confusing because the word graph isn't even there. But I'm going to go ahead and choose number 5 for data and statistics. Notice at the top of my page, this would be the exact same thing you see on a calculator, where we started out with 1.1, which is the spreadsheet of data. Now we've added a page that has the data on it. At first, the students are like, well, that's not very helpful. Well, it's not very helpful because we haven't told the software what it is we want to graph yet. You can see at the bottom of the screen and the left side of the screen, we have this command or this suggestion to click in order to add a variable. We have the data points here, but they're just scattered around with no pattern whatsoever. So I'm going to go to the bottom of the screen. Some of you I know want me to say x-axis. I'm not going to say that. I just said it, but I'm not going to say it again now. I'm going to click to add a variable. Here's why I'm not going to use that letter X here. You might say, yeah, we have an X and a Y, but really what we have are real words. We have variables that have a relationship to one another. And so I'm a big fan of actually using the name of the variable. So now you have to make a choice. What should go along the horizontal axis? In other words, what is the independent variable? Is it pints or weight? I'll give it away. Now watch what happens to the dots. This is kind of fun. Kids love this when they do this on a calculator. If I click on weight, whee, look what happens. The data points kind of float down to the bottom axis, and now we have a scale. We have a variable name called weight, and we have a scale appropriate to what was in the spreadsheet. Each page of a TI-Nspire document is connected. So the variables I used on page 1.1 are still the same variables I can use on 1.2. All right, let's go over here to the vertical axis, the dependent variable, and we only have one more option, so I'm going to choose it. I'm going to choose pints. And now, not surprisingly, to us anyway, I think we have a pretty straight graph or pretty linear model. Now, why is it linear? Well, math theory would say, well, every time we went from 1 to the next, to the next, to the next. We increased by a regular amount, by a set amount, I should say, in column A, and we did the same in column B. So the change in weight and the change in pints was constant as we moved down the data set. All right. So here's another, with this picture, students are, I think, way more comfortable answering the question, describe the relationship. As weight goes up, pints go up. Okay. So now from this, now what we need to do is put I'll just say a best fit line. We need to connect the data so that students can use that line to predict what their own body weight is. Or sorry, not predict how much their blood volume is. I always tell people that when they don't know what button to push on the calculator, when in doubt, press menu. I had a student one time who caught on to that and she said, when in doubt, menu it out. And I'm like, perfect. So if we go menu, chances are pretty good. If you press menu, you're going to get what you want somewhere in this menu. The selection I want here is analyze. And for those of you who are TI-84, 83, 82, 81 users, we have a word here that you're very familiar with, which is regression or a best fit model. Now here we have two different linear models that are available to us. We are just going to choose the first one. I know the algebra teachers that I've talked to, at least in the US, go after this slope-intercept form with y equals mx plus b. So I'm going to go ahead and click on linear. Now watch what happens immediately. Best fit line. Some kids are like shocked that, oh, wow, look, it hits every one of my data points. I'm like, yeah, because the data was made up, basically. Not only do we have the line, we have the equation for that line. So now what I'd like to do before we proceed any further and talk about that equation for a second, I want to talk about the realistic piece of this. What is y? In this problem, in this graph, y is right there, pints. And what is x? Weight. So I know that there's a math standard that runs throughout the math curriculum saying students need to be able to solve problems symbolically. And I think that's, or maybe this is, I think this is symbolically. So we have pints as y, weight as x. So let's read this as if it were using the real variables. The number of pints you have in your body, pints of blood you have in your body, is equal to that times your weight. So now if a kid is a plug and chug kind of person, they can just plug in their weight for x, multiply it by that coefficient, and it'll spit out, it being the calculator, or maybe if the kid can do it in their head, it'll spit out the number of pints roughly that they have. So let's just take let's take one that's probably pretty easy to deal with. Let's say a student weighed 100 pounds. Again, there's math staring you in the face here, and you can do some of this math without employing the use of a calculator. I know some people think of the calculator as being sometimes not the best option. So if you weigh 100 pounds and you multiply that by 0.083, if we move that decimal point 2 spaces to the right, a 100-pound person will have roughly 8.3, what label? Pints of blood in their body. Now, how much is that? How much is 8.3 or 8 pints? Well, this is where you could easily Google it or ask Siri how much that is. But there's 2 pints in a quart, 4 quarts in a gallon. So 2 times 4 is 8. So this is roughly 1 gallon of blood. A very good visual here is a milk jug, a gallon milk jug. Fill that up. And if a kid weighs 100 pounds, that's how much blood they have in their body. Let's talk about this sort of curious addition at the end. This would be in the y equals mx plus b, that's the y-intercept, which would be this over here. In real life, if a person has no weight, now listen, it's kind of a silly question. If a person has no weight, how much blood will they have? I know that's a silly question, But the answer is if they have no weight, they're not going to have any blood because they don't need it. This is 1 times 10 to the negative 14th. And I saw somebody, I think it was Jay, a little chat thing popped up, essentially 0. And the question comes up, why don't they just put a 0 there? The Nspire software and the Nspire itself doesn't like a 0 there. So they basically put a 0 there that's not officially 0. Okay. So now what I'd like to do is rather, and you guys, if you want me to find out for you, or you can actually kind of eyeball it. If you weigh 160 pounds, you can say, let's see, there's the 160, and you can go over here to about, if you can read the scale, that's 12, that's 18. This is also a very, very, very good exercise to use with students. Don't put all the numbers in on an axis and say, please fill those in, because that is graph literacy, graphical literacy. So if you weighed 160 pounds, you probably have about 14 pints of blood. What I'm going to do is I'm going to put myself out there, and if we were face to face, if we were all in a room, this is what I would ask you now. Somebody in the room, put the cursor on that line where you think I am. Now you can't see me. I know Ruth is probably one of the few people that actually knows what I look like in real life. But I'm going to click somewhere in this white space, and it could be a moment of panic. If I click there, oh no, the equation goes away, the line's still there. If I want the equation back, all I have to do is click on the line. So now we are going to use our trace function, our trace operation. Remember, fill in this blank. When in doubt, menu it out. So I'm going to go menu. We're going to go back to analyze. And if you look way down at the bottom of that menu, we have this thing called graph trace. Trace, I think, on the 84 is a little easier to find. I think there's a button still on the 84 that says trace. But notice what happens when I press trace, the cursor is now, is it on the line or on the data points? Okay, I'll just move it a little bit. Obviously, it's on the line. So this is another way. We can graphically go down to this person who weighs 100-ish pounds. It's about right there. And we can look at the the ordered pair. And that ordered pair is, first is the weight, next is the blood volume. That ordered pair can help them to locate their position on the graph. Okay, so now I'm going to go up to where I'm at. Some of you are like, whoa, really? Okay, I'm going to keep going. That's about where I'm at, I think. You know, it's not as important to me anymore, but I think that's about where I'm at, about 190 pounds. So that ordered pair means if I weigh 190 pounds, I have roughly 16-ish pints of blood, which is not 1 gallon, but 2. Jeff is a tall, lean runner. Ruth, you are a very nice lady. I'll tell you about my history here in a little bit, because not that you're interested in it, but I'm interested in it because it was shocking to me. So 15 pints of blood, 2 gallons. What I would do in my biology class is I would take 2 milk jugs, fill them up with water, and put a big healthy squirt of red food coloring in each one. And when it got to this point of showing them how much blood I have in my body, by estimate, I take those 2 milk jugs out and I plop them up on the desk. And some kids, even, some students who you think you can't trick would go, is that really your blood? I'm like, let's think about that question a little bit. No, but that's a great visual. Now here's even cooler. You can do so much with this. How much does that weigh? How much does 2 gallons of liquid, which is what blood mostly is, blood is mostly liquid. How much does 2 gallons of water weigh? Well, the old mantra is a pint is a pound. A pint of liquid weighs roughly a pound in mass or weight. So I have 16 pounds of my body, back down here, 16 pounds of me is blood. Other than your skin, I believe, blood is the heaviest single organ in your body. And people don't even think of it as being an organ, but nevertheless, it is. So if you want me to find you on here, I sure can do that. I told you I was going to tell you a little bit about my history. I'm way older than this now, but when I was in college, um, I wasn't a runner. Ruth, you would have been so ashamed. I was not a tall, lean runner at all. I was actually a shot putter. And in college, if you're going to be a shot putter, you have no, if you want to be any good, you have no choice but to be big because the ball that you're throwing or putting or whatever you want to call it weighs 16 pounds. And if you don't have the body mass to handle that thing, you're not going to throw it very far. So let me show you what I weighed when I was a junior in college. I think this was the most I weighed, and that was a long time ago. This was back in a decade that started with a 7. Okay, so let me keep going. Some of you are like, no way. Yeah, yes way. That's about what I weighed at my biggest when I was in college. So check that out. Almost 24 pints of blood. Now, the cool thing about bringing a little science into this, and I know some of you are like, I don't have a background in biology that's reliable, so I can't talk about this with my students so I don't look silly. Yeah, you can. Why does a bigger person need more blood? And the reason is they have more body. They have more cells, and every cell needs what the blood is carrying. And what the blood is carrying, both directions, to and from places, is oxygen primarily, and then carbon dioxide, and it carries food and all that type of thing to your cells. So it stands to reason that the larger you are, the more blood you're going to need. We take this when I work with students, they're hilarious. They're so interested in this. I said, how much blood do you think Shaquille O'Neal has in his body? Or depending on where you live, I don't want to make anybody mad by picking a football team that you can't stand. But let's say we live in an area where most of the NFL fans, anyway, are Minnesota Vikings fans, which I think is pretty funny because the Vikings are pretty hopeless when it comes to getting to the Super Bowl. But an offensive tackle, for example, a lineman, for any NFL team, in all likelihood weighs at least 330, 340 pounds. Some of them are even bigger than that. So if I do this and keep going up this way, you're like, oh my gosh, it doesn't go that far. I'm just going to keep pressing. Look what happens. I'm pressing my right arrow. Watch carefully. Watch the graph. I'm just pressing the right arrow. What's happening to the graph? The graph is adjusting to my wishes without me having to change the scale. I think that is so awesome. Now, yes, I still love the 84. I grew up on the TI. I learned the graphing calculator on the TI-82. The 84, as far as I know, you still have to go manually change the window. Not that this is any better than that, but it's sure more convenient. So a person who weighs 350-ish pounds has close to 30 pints of blood in their body. One more thing I want to mention about this, or not one more. Ruth is laughing because she's like, Jeff, you never just mention one more thing. And she's right. In each drop of your blood, drop. Now, I don't know how many drops there are in a pint. I don't know how many drops there are in my body. I know it's a lot. In each drop of blood, there are roughly 10 million red blood cells. Try to get your mind around that. I can't get my mind around that. There's 10 million red blood cells per drop. So that kid is going to go, I'm going to figure out how many red blood cells I have in my body. And you can do it. You can Google it and see how many drops out of an eyedropper are in an ounce and all that kind of stuff. They can figure it out. And the number is staggering. I mean, you're up in the trillions, which is crazy huge. So then the question becomes, what do red blood cells do? See, biology is one of those subjects, kind of like algebra. Nothing goes away. You just expand on it and you use it later, perhaps. Once a kid has learned how to plot an ordered pair on a graph, it's not like, well, glad that's over. No, it's not over. It doesn't go away. So that's one thing. The other thing is every year at my school, and I'm sure if you teach high school, chances are pretty good you're going to be nodding your head. Every year, 3 or 4 times a year, the bloodmobile would come to our school, set up shop in the parking lot. Kids would have an opportunity to go donate blood. Great, really, really great program. Donating blood requires two criteria of the person donating, at least two, but here are the two. Number one, you have to be, I think it's 17, it's either 16 or 17. It used to be 17 years old. They might have reduced that to 16. So you have to be of that age. The second one is the one every single time the bloodmobile came, I would have somebody stomp into my room saying they got kicked out of the bloodmobile and weren't allowed to give blood. And it was kind of like their dream. They wanted to give blood, help somebody, noble cause. Well, I'd look at this person, and usually it was a female athlete. And that female athlete usually did something like cross country. And the other requirement is a person has to have a body weight of at least 110 pounds. At least it used to be 110. So let's go back down here and see why. And this is a great opportunity for me to pull out this activity and show this really irate person why, when you weigh, well, we can just do this 98 one. Let's just do that. So let's say this person weighed 99 pounds and they were not allowed to give blood. Why are they not allowed to give blood? Well, when they take blood out of you, or they take blood out of me, or they take blood out of anybody, how much do they take? Answer, roughly a pint. It's actually 500 milliliters, which is just a little more than a pint of blood. So look at this person here. If this person who weighs right around 100 pounds donates blood, she or he is giving into that bag more than 10% of their entire blood volume. Whereas if you go back up to where I was, 190-ish, somewhere down in here, with me, I would be giving 1/16 of my blood volume. So like what, 6%, something like that, which is, now I know, I know when I give blood for a couple days afterwards, I feel kind of wonky, a little lightheaded and all that kind of stuff. Imagine if you're donating, if you're giving in the bloodmobile or the blood bank over 10% of your blood volume. The reason that they're not allowed to give blood if they don't weigh enough is it's dangerous. There's dangerous health-wise. There's other criteria, like if, especially a female, if their blood iron levels are lower, they're not allowed to give blood and so on. But the cool part about this is now there's a reason why we can do this activity with students. So then we can say, well, does this hold true for any human or any mammal? And it actually, from what I read, it kind of does. So if you think about a really big mammal like an elephant, which might weigh upwards of 6,000 pounds, you can knock yourself out trying to figure out, man alive, how much blood do they have in their body? Well, you could take 6,000 times 0.083 and figure it out pretty quickly using the scratch pad on the Nspire. Or does it hold true for humans of any age? What if this formula, let me go ahead and click, press escape, I'll click here. What if a baby is born who weighs 8 pounds? If you take 8 times that value, you will come up with a number of pints. And the answer is less than 1. So when babies are first born, they have comparatively, very, very little blood. And so they're always kind of on an edge health-wise if they run into some issues where they need transfusions or they've lost some blood or whatever, so on. Ruth, just for kicks, I'm going to try plugging this in. You want to take any bets on whether this works now? Well, I'm kind of glad that didn't work, because if it would have. Okay, Mrs. Casey,
I was thinking about it, and I speculated from the time that we checked everything well before the session started to the time it actually started. I think your computer settings had that USB port go to sleep, and it would require a full restart, not just a restart of your software. So thanks for, stepping in and doing doing that really good data analysis that we got to look at.
Well,
It was
whatever
it
the
was
cause of it,
pretty good.
I know that I'm really sweating right now. So we made it.
It was yes. I'm gonna plug another thing into the chat. I've been kind of filling up the chat over there.
You want me to stop? I'm going to stop sharing. I'll give it back to you. How's that?
Okay, I can't talk and type at the same time, so I'm just gonna from education.ti.com resources. There are some links related to what Jeff was sharing with us. Um, Obviously, if you look at those activities online, they won't have the rich background, the rich discussion that Jeff included in this session, but it's recorded. You can go back and watch it and do it and try it with your own device, your own students. All right, so I should probably share and we'll go back to the screen. We do have the chat's still rolling. So if you have a chat question or a comment to share, go ahead and put that in there. If there were links in the chat, comments in there, go ahead and copy them. Save that chat before we leave here. All righty. Let's see. The chat's going. Jeff is watching it. And now, drum roll, lucky winner. So we had people register for the event and we had people attend the event. And I'm going to put this in the chat. Remember, I can't type and click and talk at the same time. So here we go. The winner is, did I make it over there? Alejandra Sayens. So we have your email from your registration. You should be getting an email from a TI or in the next hours, days, and they'll communicate with you about the selected device.
Oh,
Okay.
Alejandro, you don't happen to be from Yazoo City, Mississippi. That would be too cool if that.
I tried to discern from the email address, but it was not
Okay.
something that I
All
could
right.
determine.
All right. San
Alejandra,
Antonio.
if you still
Yay.
have your chat open, Alejandra, go ahead and share where you are located if
San
you'd like
Antonio.
to. Or aha,
Yeah.
woohoo! All right, in the chat, I'm going to share a link for resources associated with tonight's slides. You'll also be getting this in an email as a registered participant. You'll get an email follow-up that has information, has slides, and also has a link for certificate of attendance that will be coming to you in email in addition to appearing in the chat tonight. All right, lots of stuff, lots of great information shared while Jeff was showing his screen and talking about that rich activity and also in the chat throughout the time. So thank you all for engaging there. Certificate of attendance, we sent that link out. All right. Last chance to look up and down in the chat. See if there are any questions, comments.
Great. I checked it out. I think we had a lot of thank yous. So thank you guys. You know, I don't like when certain people say this to me in certain situations when I hear thank you for your patience. They're assuming a lot, but you guys were so patient tonight and so flexible. And, you know, I know we didn't end up getting to the electronics thing, but I am so grateful that you guys hung in there. And Ruth, I'm suspecting that as usual, you were right about what happened with that driver.
Yep.
So
Just got tired of waiting on us and
you did.
took a nap. Yeah. But recall, Jeff showed us the probes in at the early portion of the video, and the chat had links to those probes, and they're easy to find from the education.ti.com site. Drop down for products and data collection. They're all right there and some links. Post webinar follow up, you'll have some resources available always. 1-800-TI-CARES. I shared that earlier in the chat with Myra, I believe, who was having a charging issue with a device that she had. You registered for this one, so check out some of the other upcoming events that there are. And thank you all so very much for joining us. Have a great evening. Thanks again, Jeff. Thanks,
Thank
everybody.
you.
This
Thanks,
is really
everyone.
kind of sad. I just waved at you. Okay,
Oh,
thanks.
oh my gosh.
All right. Have a good evening, everyone. Thanks. Bye.